I was scrolling through a technical thread the other night, the kind that usually just argues about font choices or dark mode settings. But this one was different. It was from Boris Cherny, the head of Claude Code at Anthropic, and the way the engineering community was reacting felt less like a discussion and more like they were witnessing a religious awakening. One prominent developer actually wrote, "If you're not reading this, you're already behind." I looked at the workflow Boris shared, and honestly, it didn't look like coding at all. He had his terminal split into 5 distinct tabs, number 1 through 5. There was no frantic typing, no deep focus on a single line of logic. Instead, he was waiting for system notifications, acting like a fleet commander monitoring a radar. While one tab refactored a legacy module, another was running a full test suite, and a third was drafting documentation. One observer described the scene as feeling more like a high-stakes game of StarCraft than traditional software development. You aren't the worker anymore, you're the strategist commanding autonomous units in real time. But then I hit a detail that seemed completely backwards. In an industry obsessed with low latency and instant results, Boris revealed he exclusively uses the heaviest, slowest model available. In a world where every millisecond counts, the man building the future of AI is intentionally choosing the slow lane. He isn't interested in how fast the text appears on the screen. He's looking at a correction tax that most of us don't even realize we're paying. It's a shift that turns the code base into a self-correcting organism, where every mistake the AI makes is etched into a single file to ensure it never happens again. It made me realize that while most of us are still trying to learn how to write better code with AI, the architects of these tools have already stopped writing entirely. They've moved on to a different game, and if you're still focused on the syntax, you're already playing a losing hand.
It's a completely different game. You're absolutely right. I think what you just laid out, it's not just a productivity hack. It's a fundamental change in the geometry of what work even means for a developer.
The geometry of work. I like that. It's not just about doing the same things faster.
No, not at all. It's about restructuring the whole relationship between, human intent and what the machine actually executes. When you look at all the material we have for this deep dive, Boris Cherny's own posts, the Reddit threads, even connecting it to bigger ideas like the sovereign individual, you see this convergence.
Right.
We're moving from a world where the human is the bottleneck, the person physically typing, to a world where the human is the catalyst.
The strategist.
Exactly. And to really understand what that feels like day to day for an engineer, we have to look at how it changes their actual workflow. Like you said, it's not about typing faster. It's about who or what is doing the typing. I recently came across a story about an engineer in San Francisco named Leo, who had spent a decade managing a team of 12 developers.
And like so many people in the Valley, he was just completely burnt out. The friction of managing people, the endless stand-up meetings, the egos.
The great stagnation, as the source calls it.
That's it, shipping features at a snail's pace.
So I saw this post describing how he just pivoted his entire workflow to mirror what Boris Cherny was doing.
Okay.
So instead of 12 human engineers, Leo now sits in front of a terminal with 5 distinct Claude code agents running at the same time.
Wow.
Yeah. One is handling the test suites, another is refactoring this legacy backend, a third is drafting documentation, all in real time.
And he's just watching.
He monitors them through system notifications. He described it as watching a silent, invisible orchestra. He said he went from being a code monkey to a fleet commander.
That phrase, fleet commander, it's so perfect because it captures the mental shift you have to make.
It is. And as a tech commentator, I find it fascinating, but also, a little bit heavy. There's this mix of awe and a slight chill. From, say, an E-cup perspective, this is the absolute dream, right?
The Department of One, breaking through all the limits of human coordination. We're moving to a world where innovation isn't capped by how many people you can fit on a Zoom call, but by how many agents you can orchestrate.
And some people will hear that and think, death of the team.
I'm sure they will. But I choose to see it as the birth of a new kind of creative agency. It's about giving an individual the power to build something that used to take $1 million seed round, and that kind of liberation. It's hard not to read for that.
It is. But we have to break down the mechanics of this fleet commander thing, because I think there's a huge misconception about how complex this must be.
Right. I definitely had one.
When you really analyze the technical breakdown Boris Cherny gave, the most shocking part is just how vanilla it is.
Totally. I pictured something from a sci-fi movie. A guy in a VR headset moving nodes around in 3D space.
Exactly. Or, 17 custom-trained sub-agents with these elaborate, complex personas. but that's not it at all.
It's almost mundane, which is what makes it so powerful.
It's mundane and brilliant. So what is it really? It's 5 parallel tabs in a terminal. He uses iterm 2. That's the entire command center.
It's just numbered 1 through 5.
Numbered 1 through 5.
Yeah.
And then at the same time, he has maybe 5 to 10 tabs open in a browser on claude.ai. And that's the whole infrastructure. The magic isn't in the tools, it's in the parallelization of his attention.
Okay, let's stick with that phrase for a second. Parallelization of attention. Because my brain, and I think most human brains, are terrible at multitasking. So how does that actually work in practice?
Yeah, see, that's the key. He isn't multitasking in the way we usually think about it. He's not, frantically typing in 5 different windows at once.
Right.
He uses system notifications, a ping, as the trigger. This is what allows for true asynchronous development by just one person.
Okay, explain that. What's the difference?
Well, in a normal workflow, the human is the synchronous blocker. You are the bottleneck. You type a line of code, you wait for it to build, you run the test, you stare at the screen waiting for the result. You're locked in this very linear loop.
And if you walk away, the work stops.
The work stops. Boris has completely broken that loop. He gives a command to tab 1, let's say refactor the entire login module. Then he immediately ignores tab 1. He doesn't wait. He switches to tab 2 and says, write all the unit tests for the payment gateway. Then tab 3, draft the user documentation for this new feature. He's only engaged, his attention is only required when an agent finishes its task or gets stuck and it pings him.
So he's essentially pipelining his own cognition. He's never waiting for the machine. The machines are all waiting for him.
That's a perfect way to put it. And there's a specific technical detail he mentions that makes this all so fluid. It's a command he calls teleport.
Teleport.
Yeah. And this is actually crucial. In a normal dev environment, moving your context from the command line, where the code actually lives, and runs to a web UI, where you might want to read a long plan from the AI, that's a high-friction process.
Oh, yeah. The Alt-Tab tax. You're copying and pasting logs, the formatting gets all messed up, you lose your train of thought, it breaks your flow.
Totally. Boris uses a simple command. He just types an ampersand or a teleport flag, and it instantly moves the entire active session from his terminal to the web browser. The state is handed off seamlessly.
So if he needs to see a complex architectural plan the AI just generated, he just teleports its brain to the web where it's easier to read.
Exactly. And then he can teleport it right back to the terminal to execute something. It removes all that friction of switching mental modes. It lets him stay at that high-level strategic view.
He's optimized every single bit of administrative drag out of his workflow so he can focus purely on giving direction. Which, okay, it brings us right back to that StarCraft comparison from the intro. I think for a lot of people, that's the aha moment.
It is the perfect analogy.
Yeah.
I mean, think about the difference between a first-person shooter like Call of Duty and a real-time strategy game like StarCraft.
Okay.
In an FPS, you are the soldier. Your output is totally limited by your personal reaction time, your aim, how fast you can hit the buttons. You're in the loop. That's traditional coding. You're typing every bracket, every semicolon.
And if you start typing, the code stops getting written.
Correct. But in StarCraft, you're the commander. You don't pick up the rifle. You select a group of Marines, these autonomous units, and you just click attack. You tell a worker to build a base. You're managing resources. You're managing strategy. You're giving high-level directives. The units themselves handle the mechanics of shooting or building.
So Boris isn't writing the functions. He's commanding instances of Claude to write, test, and document all at the same time.
He's the strategist. And you know how in competitive StarCraft they talk about APM actions per minute?
Sure.
But those actions aren't pulling a trigger. They're management decisions. That's why the output numbers Boris is hitting are so staggering. The sources say he's completing something like 50 to 100 pull requests a week.
50 to 100. Let's just sit with that for a second. That number it's absurd in a normal context.
Let's contextualize it. A pull request, a PR, isn't just one line of code. It's a whole unit of work. A bug fix, a new feature, a documentation update. It's been coded, tested, and submitted for review by other engineers.
Right. So a really productive senior engineer at, say, a top tech company. What are they doing in a great week?
On a great week where they're really in the zone, no meetings, maybe 5 to 10 PRs.
Yeah.
Maybe.
So we are talking about, at a minimum, a 10x multiplier in output.
At the absolute minimum. And you can bet he's not working 10 times the hours. He isn't sleeping under his desk. He's just operating at a completely different level of abstraction.
That's the Department of One concept made real.
It is, and this connects so deeply to those EAG or effective accelerationism themes that we see in the commentary around this. The argument has always been that human coordination is the biggest bottleneck in software. You know the famous book, The Mythical Man Month?
The idea that adding more people to a late software project just makes it later.
Exactly.
Yeah.
Because you spend all your time in meetings trying to get the new people up to speed. The communication overhead just explodes. 5 people, it's manageable. 50 people, you need managers. 500 people, you need entire departments, VPs.
All this bureaucracy.
Right. But if you're one person orchestrating 5 highly competent, non-human agents, there is 0 human communication overhead. You get the raw output capacity of a 12-person engineering team, but with the coherent, singular vision of one mind.
It's the ultimate validation of that do more with less strategy. You don't hire more people, you parallelize your own cognition. And this is the part that completely threw me when I first read it. You'd think to move that fast, to get that kind of output, you would need the fastest, lightest, most instantaneous tools. But Boris does the absolute opposite. I heard about a developer named Amara, a veteran software architect who was initially skeptical of the AI hype. She was tired of the low latency race where every new model was marketed as faster than the last, only to hallucinate more efficiently.
Hallucinate more efficiently. That's good.
She decided to experiment with the Opus 4.5 model, following the logic that intelligence matters more than speed when the stakes are high. So, you can imagine Amara in her home office purposely choosing the slow model for a really complex system migration. While her peers were chasing these instant responses, she allowed her agents the cognitive compute time to actually think through the architectural debt.
She gave them time to think.
Exactly. And she used a version of this claudie.md file, the shared memory log, that recorded every single previous failure and every edge case. So whenever an agent stumbled, it didn't just fail, it learned. It documented the error, and it made sure the next agent wouldn't make the same mistake.
It becomes a learning system.
Right. And watching this from a distance, I realized Amara was part of what some people are calling a Promethean shift. My feeling is that we've been stuck in this period of fast but shallow development for years, and it's led to all the fragile software we use every day. Seeing Amara prioritize that high-level intelligence over just raw speed, it gives me hope. It's a reminder that real progress isn't about doing the same things faster. It's about having the intellectual horsepower to solve problems that were, before this, basically unsolvable. It feels like a move away from the move fast and break things era.
Toward a think deeply and build permanently era.
Yes, exactly.
Think deeply and build permanently. That is the core philosophy. And the sources have a name for the problem this solves. They call it avoiding the correction tax.
Let's unpack that. Correction tax, because on the surface, choosing to wait for a thinking model like Opus 4.5, it feels agonizingly slow. We've all been conditioned by the last couple of years to expect text to just stream onto the screen the second we hit enter.
It does feel slow in the moment.
Yeah.
But that speed is a complete illusion. Boris's rationale, which he lays out in that Reddit thread, is that he uses Opus 4.5 with thinking for everything. It's the heaviest, biggest, slowest model they have.
And why?
Because in his words, you have to steer it less. Just think about the alternative for a second. You use a fast, lightweight model, it spits out code instantly.
It looks good.
Looks plausible. You copy it, you paste it, you run it, it crashes.
Yeah. I think every single person who's ever coded knows that pain intimately.
Right. So now what do? You have to read the error message. You have to figure out what went wrong. You paste the error back into the chat. You have to explain to the bot why it was wrong. Then the bot apologizes, which is always kind of annoying.
It is.
And it gives you a second attempt. And maybe that attempt fixes the first bug, but it introduces a subtle new one. You could easily spend 20 minutes in this back and forth loop, that 20 minutes. That is the correction tax.
Whereas the slow model, Opus 4.5, might take, what, a minute to generate the first response?
Maybe even 2 minutes for something complex. It just sits there. You see the little thinking message. It's running its own chain of thought process. It's evaluating edge cases. It's checking its own logic against the docs you gave it. And then it outputs the code.
And if it gets it right the first time.
If it gets it right the first time.
Right.
Because it actually thought about the problem, your net velocity is way, way higher. You just save yourself 19 minutes of frustration by being patient for 1 minute.
This really gets at that great stagnation idea from the source material. We've been limited by how much complexity a single human brain can hold in its working memory at one time.
That's the ceiling.
And by maximizing what you called cognitive compute, literally buying intelligence with processing time, We can finally break through that ceiling.
It's about shifting the metric. We need to stop measuring tokens per second and start measuring correct decisions per hour.
That's a great way to frame it. And a huge part of maximizing that intelligence seems to be this claudie.md file that you mentioned, this idea of a self-correcting organism. I was fascinated by this. How does a simple text file do that?
It's one of those ideas that's so simple. It's brilliant. The claudie.md is just a markdown file. It's checked directly into the project's Git repository, just like any other piece of code.
So it's version controlled and shared with everyone.
And every AI agent. It acts as a hard-coded institutional memory for the project. And the rule Boris follows is simple. Anytime we see Claude do something incorrectly, we add it to the claudie.md.
So instead of just telling the chatbot in the moment, hey, you forgot to use our special internal library, and then it immediately forgets that 5 minutes later in a new session.
You write it down, you codify the lesson, and because that file is automatically included in the context window for every new agent you spin up, every single instance of Claude from that point on knows not to make that specific mistake again.
It's not like the vague, fuzzy memory of something like ChatGPT. This is rigorous, project-specific instructions.
Exactly. Give me a concrete example. Let's say your project has a really specific non-public internal database schema. A generic AI will just try to write standard SQL queries that don't fit your system. It'll break the build every time.
Right.
So in your claudie.md file, you add a new section. Project database rules. Always use the fetch user safe wrapper function. Never query the user table directly. From that moment on, every agent, forever, will follow that rule. The file grows over time, and the codebase basically immunizes itself against common, recurring bugs.
It gets smarter the more you work on it.
It's like you're leaving a sticky note for the next developer, except the next developer is an AI that reads every single note instantly and follows them to the letter.
That's incredible.
And Boris takes it even one step further. He uses something he calls a post-tool use hook.
Okay, what's that?
It's automation that runs after Claude writes the code to handle things like formatting. He doesn't waste precious tokens in cognitive compute asking the AI to please make sure this is formatted according to our style guide.
He just lets it generate the raw logic.
He lets the AI do the thinking, and he lets a simple, dumb script do the grunt work of formatting. It's about optimizing what each component is good at.
Which seems to be the philosophy behind the slash commands as well. I was reading through the list, and they sound like cheat codes in a video game. Commit, push, PR.
It's basically bureaucracy automation. I mean, think about all the friction involved in making a single commit in a normal workflow.
Oh, it's a lot. You type git status to see what you changed. You type git add, then you sit there for 5 minutes trying to think of a good commit message.
And you usually just end up typing fix stuff or whip.
Guilty.
Then you have to get pushed. Then you have to go over to GitHub or whatever you use, click new pull request, fill out the template. It's all this low-level administrative drag.
So he automated that entire chain
into a single command. The agent checks the status. It writes a perfect descriptive commit message based on the actual code changes it just made, which is almost always better than what a human would write. It pushes the code, and it opens the PR, all from one command.
That is wild. And he has other agents too, right? Like Code Simplifier?
Yes, he treats them like a toolbox of specialized workers. Code Simplifier is a script you can run that tells an agent to go back over the code and clean up the architecture. Verify app is another one. It's a modular approach to applying intelligence. You don't have one giant AI doing everything. You have these specialized tools you deploy as good.
This level of automation, it starts to feel like you're building something that can run itself, which actually leads perfectly into the next story. Because if the code can write itself and it can fix itself, what happens to the whole idea of human management or quality assurance? Try to imagine a developer named Marcus working out of a small hub in Berlin on a decentralized finance protocol.
Okay.
Marcus was frustrated by what he called bureaucratic safetyism, all the layers of human oversight and gatekeeping that often care more about playing it safe than actual security or innovation.
The committee meetings about the committee meetings.
Precisely. So he started building a self-correcting code base using what he called autonomous verification loops. In his setup, his AI agents didn't just write code. They were forced to prove that it worked.
How?
By spinning up their own browsers, running bash commands to test the environments, executing these exhaustive test suites, all before Marcus even saw a pull request.
So the verification is part of the generation process.
It is. I saw online that this system became a sovereign tech stack, something capable of maintaining itself without a centralized QA department or a compliance board breathing down his neck. I'll admit, when I first read about Marcus's autonomous loops and his dismissal of traditional gatekeeping, it felt a bit radical, maybe even a little right-wing in its techno-optimism,
It challenges the whole idea of institutional oversight.
It does, but then when you look at it just through the lens of pure engineering excellence, I can't help but feel this sense of relief. If the code can literally verify itself and correct its own flaws with rigorous automated logic, isn't that the ultimate form of safety?
It's a different kind of safety, a more robust one maybe.
It feels like we are seeing the foundation of a future where technology is decentralized, not just in where it lives, but in how it is governed. A world where the truth is in the verification loop, not in the committee meeting. And that future feels both inevitable and profoundly empowering.
Truth is in the verification loop. That's a really powerful statement. The story of Marcus connects directly to this idea of autonomous verification loops, which the sources we're looking at say is the real unlock for AI-driven development.
Because it's not enough for the AI to just generate code. We've all seen it generate complete garbage. If you just automate the writing but not the checking, you've just built a very efficient garbage factory.
You've built a garbage factory. And if you rely on a human to manually verify every single line, you've completely defeated the purpose of the automation in the first place.
Right.
We should look at that self-healing software systems research paper here. It uses a biological analogy that I think is perfect. Your body doesn't need to call a doctor to fix a paper cut.
The immune system just handles it.
The immune system detects the breach, it signals the repair agents, the platelets, the white blood cells, and it fixes the problem autonomously. The software needs its own immune system.
So in software terms, that's the verification unit.
That's the verification unit. Boris Cherny describes this part vividly. He says Claude tests every single change it makes using a Chrome extension. It doesn't just guess that it worked. It literally opens a browser instance, it clicks the buttons on the screen, it tests the user interface, and if the test fails, it iterates.
So it's in a loop. It writes the code, runs the app, sees it crash, reads the error log, rewrites the code, and tries again.
All of that with zero human intervention. It keeps looping until the test passes. Boris claims this single practice increases the quality of the final result by 2 to 3 times. It's a biological immune system for your code base.
That's a huge shift from traditional testing, where a human writes a test and then the code either passes or it fails. And if it fails, it creates a ticket for another human to fix.
The loop is now closed. The AI writes the code, writes the test, runs the test, and then fixes its own code.
This feels like it has much bigger implications than just writing cleaner code. The sources start bringing up things like Citadel FOSS and connecting it to the philosophy of the sovereign individual, this idea of a sovereign tech stack.
This is where we have to zoom out from the code to the political and economic philosophy behind it. The sovereign individual is a really seminal text in this whole space. It argues that the structure of society is determined by something called the efficient scale of violence.
Okay, that sounds pretty intense. Scale of violence. What does that mean for a coder like Marcus in Berlin?
Historically, to build and secure something big and important, like a national banking system or a huge software platform, you needed a massive corporation. You needed a fortress, an army of lawyers, a giant QA department, layers and layers of management.
What Marcus called bureaucratic safetyism.
That's the one. That bureaucracy is the tax you pay for safety and scale. You need the big corporation to shield you from risk. But what happens if your fleet commander and your 5 AI agents can build a system that self-heals and self-verifies?
Then you don't need the fortress anymore.
The efficient scale of production just collapses. You can have a Citadel tech stack, like the decentralized finance protocols mentioned. Things like CoinSwap that can be built and maintained by a tiny group or even a single person with no trusted third party.
The code's security is guaranteed by the code itself through these autonomous verification loops, not by a corporation.
And that empowers the sovereign creator over the employee. The sources draw this line between employee-owned entities, which are incentivized to grow bureaucracy and play it safe, and sovereign owners, who are incentivized to create and maintain real value. Boris's workflow is the practical technical application of that entire philosophy.
It's the technology that enables the sovereign individual to actually exist.
It allows one person to manage a level of complexity that, until now, required massive bureaucracy.
It's kind of incredible to think that a simple terminal setup and a Chrome extension could be the tools that start to dismantle the 20th century bureaucratic firm. But, okay, let's take a breath here. Because it all sounds perfect. It sounds inevitable. What are we missing? What are the invisible levers that could triple this up?
Right. There's always a trade-off. We have to do the reality check, and the Reddit discussion about ChatGPT versus Boris gives us a big one. Load management.
Meaning, what happens when everyone starts trying to use these giant thinking models like Opus 4.5 all day long?
Compute becomes scarce. And the AI companies might start cutting corners to manage that load.
And you, the user, might not even know it's happening.
They already do it, and frankly, they have to. The sources talk about two main techniques, quantization and dynamic routing.
Okay, can you unpack this for us? What's quantization?
Quantization is basically lowering the resolution of the model's brain. Imagine you have a beautiful high-resolution 4K photograph. To save file space, you compress it into a small JPEG. It looks mostly the same at a glance, but if you zoom in, the fine details are all pixelated and blurry.
And how does that apply to an AI model?
Instead of doing its calculations with high-precision numbers, let's say in INS8, they might dynamically drop it to a lower precision INS4 to save compute and make it run faster. The intelligence, the nuance, drops just a little bit.
And dynamic routing, or speculative decoding.
That one's even trickier. Think of it like the predictive text on your phone. A smaller, faster, dumber model generates a guess for the next few words because it's cheap to run. Then the big smart model just glances at the guess and verifies if it's good enough.
So it's not truly thinking through the problem from scratch?
It's a shortcut. It's faster, but it significantly increases the chance of subtle, hard-to-find logic bugs slipping through. And the scariest part is you would have no idea it's happening.
That's the invisible lever. The degradation is, what, subtle and statistical, as the source says.
Exactly. If you're just asking it to write a simple email, you'll never notice the difference. But if you're Boris Cherny and you're asking it to perform a complex refactor across a massive code base, you are precisely the kind of user who will be bitten by those subtle logic bugs. You think your fleet is operating at 100% intelligence, but the provider has silently throttled you down to 80% because of heavy traffic.
That is a terrifying thought for a sovereign engineer whose entire stack relies on the integrity of that intelligence. You're building your castle on land that can shift under your feet without any warning. And speaking of what you're relying on, there's the cost. This can't be cheap.
It's definitely not cheap. The analysis in the threads pointed out that a workflow like this uses millions of tokens. One estimate was around 2.4 million tokens in a single session.
For a regular person paying the retail API prices, what does that translate to?
Well, at around $5 per million tokens, that could be $70, maybe even $100 a day.
Wow. Okay, so the Department of One comes with a $3,000 a month utility bill.
Which, yeah, that sounds really high if you're a hobbyist just messing around. But you have to flip the perspective. Compare $100 a day to the fully loaded salary of 12 software engineers in San Francisco.
Right. When you put it that way, you're spending $3,000 a month to save $300,000 a month. It's not even a question.
It is a massive, massive deflationary force on the cost of producing complex software. Even at $100 a day, it is orders of magnitude cheaper than the human alternative.
So last question then. Does that mean the human just becomes a button pusher, a glorified wallet? If the AI writes the code, tests the code, documents the code, and commits the code, what is actually left for us to do? Are we just here to pay the bill?
This is the most critical final distinction we have to make. The human role doesn't disappear, it elevates.
Yeah.
That ArtSafe paper we mentioned talks about a diagnosis module, but it always acknowledges that the intent has to come from somewhere.
The what?
The why. The human role shifts away from what we could call syntactic execution. Typing the brackets and the semicolons and remembering the function names. It moves to semantic architecture.
We become the architects.
The architects and the ethical guardians, to quote that Science article. The AI is a brilliant tool for handling syntax. It handles the how, but the human provides the what and the why. You're no longer judged by how fast you can type. You're judged by the clarity of your logic and your ability to verify the truth and the purpose of the system you're building.
It's a complete reimagining of the job description for an engineer. Okay, let's try to synthesize all this. We started this deep dive with what felt like a religious awakening in a technical thread online. But as we've peeled back all these layers, it's clear this isn't about a new religion. It's about a new mode of production.
It's the industrial revolution for code. We're moving from a world of hand craftsmanship to one of industrial orchestrations. But And this is the key difference, without the soul-crushing bureaucracy and scale of the 20th century factory.
It allows the individual to retain that spirit of craftsmanship while leveraging the scale of the machine.
That's a powerful combination.
It really is, and that's such an important place to land. Because most people are going to look at Boris Cherny's workflow, and they're just going to see a coding tip, a new productivity hack, a way to finish their work faster. But the sovereign listener, the person who is really, really paying attention, they see the beginning of the end for the large-scale bureaucratic firm. They see a future where a small, focused group or even a single person can build and maintain systems that used to require an army. If you are still debating font sizes or dark mode settings while engineers like Boris are running 15 instances of Opus 4.5 in parallel, you aren't just behind. You're playing a game that has already been solved.